to Mechanical Pros. I'm here with Brian, and we're going to be talking about how to replace a bearing. Brian, tell me what we're looking at here.
Absolutely. So what we're using today is called an induction bearing heater or a magnetic bearing heater. So these have been out for a while now, replacing some old school technology the way guys used to do it in the field. Much better way to use this bearing heater. This is NTN brand, a fast therm is what we've been using. Had a lot of success with this, but there's several brands of bearing heaters out there. They all do a really good job. The main points on these bearing heaters and why these are preferred over the other methods of previous years, which would be either a hot oil bath, which is terribly messy. You got to take the bearing somewhere and do all that. Tough to do. And then the other way would be toaster ovens. Believe it or not, 20 years ago, we would heat bearings up in toaster ovens. And the main purpose to heat your bearing is to expand that metal, because the size of this bearing is almost exactly the same size as your motor shaft, just barely bigger, right? So no clearance hardly at all. You're never going to slide that bearing over a shaft without heating it up and expanding the size of the bearing. So even though it only spans a little bit, that's all you need. By doing that, you take away all the need of force, trying to force a bearing on, trying to beat it on with a dead blow hammer, possibly damaging the bearing. So it's critical to heat the bearing up. A big benefit of heating it up this way is you get a precise temperature. We're going to heat this bearing to 230 degrees, and that's exactly the temperature it'll be. In the past, if you would use, toaster ovens, things of that nature, you don't really know how hot you're getting that bearing, and the risk you run with doing that is overheating the grease in this bearing, damaging the internal components of the bearing, so it's critical not to get the bearing too hot. So we're going to show you today the method to use the magnetic induction bearing heater.
Very cool.
Very cool.
So knowing the temperature of your bearing is important.
Critical.
Not
critical.
overheating it. It's going to protect the oil. It's going to make your bearing last.
That's exactly right.
You overheat it, all that work you're doing is for naught. Yep. You're going to put a bearing in. It's not going to last a full life.
It's not. Bearing. That's exactly right. It'll run. It'll get you out the door, but you're probably not going to get a return work from that customer, because he'll have another company in there changing the bearing before too long, because you've damaged it by overheating it. Or if you're not using a bearing heater and you're trying to beat it on with a dead blow hammer, again, you're going to damage the bearing. So super critical. A couple things to talk about on these guys right out of the gate. Very safe product. The one thing that they do have in the literature on all of them is, because it's electromagnetic, if you have a pacemaker or any kinds of nice wristwatches and you're right up on top of it, that's not good. But that goes for microwave ovens too, right? So, just have to get that disclaimer out of the way. So we're going to start roughly talking about what temperature we want to set this at. It's preset to 230 degrees. That is the temperature that you want to heat your bearing up. I can change it, but it comes defaulted to 230. What you really want is a 160 degree temperature difference between the shaft that you're going to slide that bearing on the bearing itself. So if you got your bearing at 230 degrees, you got a 70 degree temperature. This is a good rule of thumb. If you're in a 70 degree room, 230 degrees. But just remember, 230 is a good rule of thumb, but if you're in a room that's 100 degrees, which a lot of mechanical rooms are, you may need to heat that bearing up just a little bit more. You want about 160 degree temperature difference between the shaft you're going to slide that bearing on and the bearing itself.
So the bearing heater, specifically designed for it, allows you to get that bearing to that right temperature. At what point do you think you're going to be starting to burn or melt or affect this?
Yeah, I wouldn't probably go over much more than 250.
Okay.
If I was in a super hot mechanical room, I may still try it around 250 to see if I can get it on there, because that's a good point, John. There's going to be a limit where you get this too hot, and we want to avoid that. 230 is perfect. If you can get 160 temp degree difference at 230 degrees, that's the ideal temperature to have this bearing. You're going to slide it on there with no issues. So we'll go through a couple quick steps of how this works. First thing, always leave your bearing packaged until you're ready to use it. Don't set it out on the table. Don't give it any chance to get dirty. We want to keep everything as clean as we can, including the mating surface we're going to put the bearing on. Before we ever get this out of the box, we're going to get our motor, we're going to clean the shaft, sand it, clean it, wipe it down with degreaser. We got to make sure everything is as clean as we can get it. After that point, we'll come over here to our bearing heater and we'll turn it on, and we'll sort of show you a quick process. I'm not going to go through the whole process of heating it up to 230 degrees, but we'll turn it on and kind of show you how it works. So first step is you got these different bars. Now there's different size bars. These bars here have a purpose, as does this one. There always has to be a bar crossing them. the kit, whichever bearing heater you buy, will have different size bars. So some of your bearings will fit over the center bar and can hang like that, horizontal. This size bearing that I've got is such a large bearing, as you can see, it's not a tight fit, right? You want a fairly tight fit in there. So that's not gonna work for me. That's why they give you this platform. For the bearing we have, we would use this platform here. Much tighter fit, still not touching all the way around, and you don't want it touching all the way around, but you want it a fairly tight tolerance there. Put that guy on, and now you're kind of ready to turn it on. It's pretty much do it yourself. It's a pretty simple thing. But one more critical component to this is our thermistor. This is going to tell us what our bearing temperature was. It always goes on this inner race. So I'll take that off and kind of show you. Got the inner race to the bearing here. You always want to put your thermistor on this inner race. That's because that's the part that's going over the shaft, right? So that's what we need to make sure is 230 degrees. So put that guy on there, put it all together, turn it on, comes right on, and it already tells me I'm set for 230 degrees. If I cared to change my temperature, I could do it with the plus and minus arrows right there, but that's what I want, 230. Simple as this. Hit go. And it's starting. Makes a little bit of noise. It's displaying, so my temperature is 84 degrees right now. We're gonna, and believe it or not, this goes pretty quick. Within 3 to 5 minutes, we'll probably get to 230. One really cool feature to me about it is this stays room temperature. The bearing gets hot, not these blocks. So you don't have to be too concerned about burning anything. You know, the only thing you want to be cognizant of is that bearing temperature getting hot. So we'll watch it, we'll let it get up, you know, a little bit. We'll probably not sit here for the whole 230. But as you can see, we've already gained 10 degrees, and I think I've only been talking 30 seconds since I turned it on. So pretty quick process.
Brian, how long do you think it would take with the toaster oven?
It depends.
It's a while.
It's a while. And again,
you don't know where you are.
You don't really, you know, you can set a temperature on it, but they're toaster ovens, right? They're not really made for it. I've used them. I've used a floodlight before and set a bearing on a floodlight because, you know, we just had to do what we had to do back then. But now we've got, and this technology's been out for a little while. The prices continue to come down. More products out there for it. It saves you so much time. And time is money in this business. So if you just take care of your tools and you got one of this, you will, the ROI is going to be really fast on this product. So, you know, we kind of showed what we did, but one thing we want to stress, all this is cool, right? That bearing's not. In any kit you get, it's going to come with a set of high temp gloves to put on. So you got to obviously make sure you put temperature resistant gloves on, because now you've got to pick this 230 degree bearing up and move it over and slide it onto your motor shaft. Another reason why you need these gloves, don't just let it go immediately, because the bearing's still hot, so it's a little wider than the shaft is, right? So you want to hold that bearing on there for at least a minute or so and let it start to cool off. As it cools off, it shrinks and it's going to seat on that bearing. Job done.
Thanks, Brian. Hey, if that was helpful for you, check out Mechanical Pros, subscribe, and check us out for more education coming your way.